All right, in this video we're going to talk about Unit 2, Objective 4, the chain rule. So chain rule is going to be when we try to differentiate a composite function. So one function inside the other. So if we have two functions f and g and they're both differentiable, then the derivative of f of g of x is going to be f prime of g of x times g prime of x. So we're going to be trying to find these different layers, if you want to think about it that way. Functions inside functions. So our layers that we're going to be trying to find are oftentimes going to be set apart with parentheses. And one thing that we don't want to forget is that radicals are going to be parentheses, right? We can think of the square root of x plus 1 as x plus 1 to the 1/2 power. So a couple things that we kind of want to think about is the first is we only want to take one derivative at a time. The biggest mistake a lot of people make with chain rule is they're going to take derivatives of both the outside function f and the inside function g at the same time. And if we look at the rule, we want to take the derivative of the outside function, keep the inside function the same, and then multiply it by the derivative of the inside function. So we should only be taking one derivative at a time. Some people like to call this the onion rule, because we're going to be peeling away layers at a time, like an onion has a bunch of layers. So we're going to take derivatives of layers, the outer layers before the inner layers. And again, those layers are going to be set off with parentheses. So what this can look like would be something like this. Find f prime of x if f of x is equal to the square root of x squared plus 3x. So just like when we were taking power rule derivatives, we don't want to think of this as the square root of x squared plus 3x, but x squared plus 3x to the 1/2 power. So now we see we have these parentheses here, parentheses to the 1/2. So we can think about that parentheses to the 1/2 as my outer function, and my inner function would be this x squared plus 3x. So I know we called this f here, but if we think about the definition we had, they used f and g, so I'm going to use f and g here. The inside, that g of x, according to our definition, is going to be our x squared plus 3, or 3x rather, because it's inside this other function that would be x to the 1/2. So if you were to take this x squared plus 3x, put it in here for this x, we would get this stuff here. So that's where our composite function is going to come into play. If we think about our rule, though, we want to take derivatives one at a time and work from the outside in. So f prime of x is going to be the derivative of the outside part. So parentheses to the 1/2. So we drop the 1/2. Keep the inside the same, right? So it's f prime of g of x. So this stays the same on the inside. We would subtract 1/2. Or I'm sorry, subtract 1 to get negative 1/2. So again, the derivative of just x to the 1/2 would be 1/2 x to the negative 1/2. So we get that there. And then we want to multiply that by the derivative of the inside. So we're going to multiply that by 2x plus 3. And that's going to be your chain rule. So again, we take the derivative of the outside function, keep the inside function the same, and then multiply by the derivative of the inside function. So just like with product and quotient rules, AP is going to like to ask questions with tables. So if h of x equals f of g of x, find h prime of 1 given the information in the table below. So we're going to have to think h prime of x is going to be equal to, well, this is just the definition of chain rule. So we're going to say f prime of g of x times g prime of x. And they want to know what happens when we plug 1 into our derivative. So we're looking at f prime of g of 1 times g prime of 1. So if we look g of 1, so g of 1 is going to be 3. So we're looking at f prime of 3 times g prime of 1. F prime of 3 is equal to 2. G prime of 1 is also equal to 2. So f prime of 1 is equal to 4. So the big thing we need to get out of our chain rule is we want to take one derivative at a time and then work from the outside in, keeping everything the same. So the derivative of the outside function, the part that's outside of parentheses if you're looking for it there, keep the inside of the parentheses the same, and then multiply by the derivative of what's inside those parentheses. So that's going to do it for this video. We'll see you in the next one.